Oh, here's another example of how to determine whether a curve has a tangent at the indicated point. All right, here's another piecewise graph, and this is the sixth example. If you recall in our previous one of the keys is that we want to try to determine, all right, if it does have a tangent once again meaning derivative. All right, so we're trying to figure out if there's a derivative, okay, at x equaling 2. So we need to figure out, and we're going to use the alternate form, the limit as x approaches 2 for f of x minus f of 2 over x minus 2. Okay? And if that is going to be, if this exists, then this has to be true. The limit as x approaches 2 to the right of this slope, f of x minus f of 2 over x minus 2, has to equal the limit as x approaches 2 from the left of f of x minus f of 2 over x minus 2. And once again, this is the alternate form of definition of derivative, which is a slope. So remember, all right, the slope to the right of 2, slope to right has to equal slope to left. Okay? So without further ado, let's see if we can figure this out. Well, first off, to figure out the right slope, we're going to look at this one right here. So we're going to take the 2 value, okay? And if you look at this, well, 2 is going to be greater than, which is going to equal that equation. So we're going to find the slope using this equation right here. So we're going to take 4 minus x over 4, that's f of x, minus f of 2, so we plug in 2, and that should equal 1/2. And we're going to take that all over x minus 2. So we're going to find out that limit as x approaches 2 to the right. Okay. In doing so, we can realize that we might need a common denominator. So I'm going to eliminate this denominator by multiplying everything by 4, top and bottom. All right, just to get rid of that denominator. So when we do that, we have 4 minus x. That's going to be minus 2 all over 4 times x minus 2. Doing so, we can simplify this a little bit, and we have negative x plus 2 over 4, and then x minus 2. All right. Go a little bit farther. All right. And you realize that, hey, these are pretty close. We're going to factor out a negative. So we have x minus 2. We have 4. We have x minus 2. Take the limit as x approaches 2 to the right. And we realize we'll get 0 over 0, but cancel that out. And then we're left with is negative 1/4. So it appears we have a slope of negative 1/4 to the right. So our slope is negative 1/4. Now, we want to verify, is that the same slope, all right, as we approach 2, all right, to the left. And so to the left would mean all values to the left of 2, so we're going to be using that function, 1 over x. All right, so using that rational function, we're going to set this up. We're going to take the limit as x approaches 2 to the left. We're using f of x, which is 1 over x in this case, minus, plug in the 2, 1/2, all over x minus 2. All right, we get 0 over 0 and plug that in there, so we're going to simplify this by finding common denominator. Common denominator appears to be 2x, so we'll go 2x, 2x. What we're left with is then, we have 2 minus x over x minus 2, and then times 2x. All right, from here, very close like the other one. We are close to cancel this out, so we'll factor out an x, and we'll have x minus 2 over x minus 2 times 2x. Let's take the limit as x approaches 2 to the left now. Cancel, cancel, and we get, once again, negative 1/4. All right, negative 1/4. Looking at that, we approach the same value. We have the same from the right. We have the same from the left. So the answer, once again, in this one is yes. Yes, it does have a tangent line at x equaling 2. All right. Yes, there is a tangent at x equaling 2. And that tangent is, all right, f prime of 2 is going to equal negative 1/4. All right. So hopefully this was another good example. I'm going to do one more example and how to use the calculator to help maybe expedite this process. So that's going to be example number 3. Okay, so hopefully this once again helped you determine whether or not a function using the slope definition, alternate slope definition of a derivative to help us determine that. All right, good luck and God bless. Any other problems?